Okay, here we are looking at lesson number 6, which is really going to be some of the stuff you learned in grade 9, but we're going to need to make sure we know it inside and out, especially being able to come up with the equation of lines. Because pretty soon our lines aren't all going to be straight, they're going to be very curved, and we need to be able to handle that situation. So here we are looking at a line, and if you remember, lines come in the form y equals mx plus b. And now let's take a look at each of those things. So the y, we know that this is just going to be the y coordinate of our point. And we know that the x is going to be the x coordinate of our point. But do you remember about the m and the b? Well, let's take a look at the m first. So the m is what we call our slope, and that's really what today is focused on. Our slope is how fast or slow a graph rises or falls. So what I mean by that is I have my little graph over here. This is pretty normal slope. It would have a slope of about 1. But if I wanted to really beef this up, I could say this thing's rising very, very fast. This has a fast slope. We can also have a very slow slope, something like that. That would be a slow slope. Now, the cool part about slope is they can either be positive or they can be negative. And how do we know? Well, all of those are what we call positive slopes. And the reason they are is because they rise to the right. So even this green one here is slowly going up. The blue one is going up very, very fast. Let's take a look at what a negative slope looks like. So if I have the same graph, a negative slope looks something like this. And just like before, we can have a very fast or high negative slope. So this would be a negative fast slope. Or we can have a negative slow slope. So this is what we call a negative slope. And we know that because it falls to the right. So nice and easy to remember. That's slope. But how do we find our slope? So the way we find our slope, which is also called the letter m, is a formula called rise over run. And what rise over run means is if we have this graph here, and this point is point 0, 0, and maybe this point over here is 2, 2. How do I know what the slope is? Well, what you need to do is you need to take a look at how much does this thing rise from this point over here to this point over here. So you would count how much do you have to go up in order to make that happen. Well, it's very easy because you just take a look at our little y points here. We started off at 0, we ended up at 2, so how many spots did we move up? Well, of course we moved up 2 spots. And then what's our run? Well, our run is how far over we move. So from this point all the way over to this point. And how do we look at that? Well, here we look at our x coordinates. We started off at 0, we went to 2, so this thing also has a run of 2. So to calculate it, you take your rise, and our rise was 2, divided by our run, and our run was 2, which gives me a slope here of 1. Notice how it's positive 1 because it's moving up to the right. Makes sense. So that's a little bit about slope. We're going to get into it with a couple more examples in just a bit. But let's take a look at the other part. The other part is this b value here. The b value is what we call the y-intercept. And this is very easy. It's the easiest part of this entire thing. Y-intercept is where the graph crosses the y-axis. So what that might look like is if I have this graph here, and then I have this line, the y-intercept is this value here. It's where it crosses the y-axis. So maybe that is a value of 2. In that case, we could say my b value equals 2. Let's take a look at another one. If I draw this here, and here's my graph, and I said this is -4, well, what would my y-intercept be in that case? Well, it's crossing at -4, so my b value would be -4. Perfect. So, a very quick review of some of the stuff you learned in grade 9, but now let's look at applying it. And the way we apply it is lots of times we like to use what we call tables of values. And we determine that rate of change, which is another word for slope. So how do we do it? Well, they gave us the formula right here. They said y equals 2x plus 5. So what you do is you're going to take that formula, y equals 2x plus 5, and we are going to try it for a bunch of different x values, starting with 0. So instead of x, we're going to substitute 0 in, plus 5, and now using your calculator, you just put that line right in your calculator. So 2 times 0 plus 5 gives me a y value of 5. So the first one, my y value was 5. The next time we do it, y equals 2 times x, but now my x value is 1. So I'm going to use 2 times 1 plus 5. And again, put it right in your calculator, you're going to get a y value of 7. And we could keep doing this. We could do it for our 2. So y equals 2 times 2 plus 5. And my y value equals 9. And these are all coming from this exact same equation here. We're just testing it with a bunch of values. And if I did it for 3, I would get 11. If I did it for 4, I would get 13. So how do I calculate my rate of change? Well, what I do is I start with the value below, and then I subtract the value above. So I'm going to take 7 minus 5. That gives me a value of 2. And I'm going to do that for every point. So now I'm going to start with my 9, and then I'm going to take away my 7. So for this, I got 9 minus 7. That also equals 2. And I could keep going. 11 minus 9 equals 2. 13 minus 11 equals 2. That gives me my rate of change. And guess what? All of these things are the same. Yay. Which means if the rate is equal, we have a straight line. So in this equation, I know that my slope, which is my rate of change, is going to be equal to the value of 2. Okay, perfect. Now let's take a look at calculating the slope when we have an equation on our hands. So we're going to do the exact same thing. We're going to take this equation here, y equals -3 times x plus 2, and we're going to try a bunch of different x values in here, starting with -2. So I'm going to take that, I'm going to substitute the -2 in, and I'm going to add 2. If you do that on your calculator, that's going to give you a value of +8. Next, I'm going to do it for y equals -3. Now I'm going to use my -1 value plus 2, and that's going to give me a value of 5. And I could keep doing this. 3 times 0 plus 2, that's going to give me a value of 2. 3 times 1, that's going to give me a -1. And then if I kept going, that would give me a value of -4. So let's zoom in on this graph a little bit, and let's get to plotting. So 1, 2, 3, 4, 5, 6, 7. I'm going to need an 8. -1, -2, -3, -4, -5, -6. 1, 2, 3, 4, 5, 6. -1, -2, -3, -4, -5, -6. Remember, of course, this is our y-axis, this is our x-axis. So let's take a look at our first point. So our first point is these two things here. Our x value is -2, our y value is 8. So that's our first point. So what we'll do is we'll move to our -2 over here, and then we'll go up to our 8. So our first point is that point right there. The next one is -1 and 5. So I find negative 1 on my x-axis. I go up to 5, and that's my next point. If I keep going, 0 and 2, so I find 0 on my x-axis, I move up to 2, then I find 1 and negative 1, and then 2 and negative 4. Perfect. I will connect all these things up. And now I want to be able to answer a couple of questions about this because this is going to be important. First off, if I have y equals mx plus b, and I asked you, what is my y-intercept here? Well, how do you know? Well, you can take a look at the graph and you can see, yep, this thing is at the value of 2, so my y-intercept should be 2. How else do you know? If you didn't have the graph in front of you, all you need to do is take a look at my equation here and say, what is my b value? My b value here is 2, and that's the exact same value we found by graphing it. So my b value, or my y-intercept, is 2, and if I had to write that using points, well, what would be the point here? We found it right here. The point is 0, 2. So I found my y-intercept. What about my slope? How do I calculate my slope? Well, my slope we know is m, which is rise over run. So I'm going to take any 2 points. Maybe I'll take this point here, so I'll highlight it. I'll take this point here, and I'll take that point there. So I'm going to start with my further point, always. So my m equals my rise. So what's my rise? Well, I start off at 8, and I have to move down to 5. So I go down this distance here. How far did I go down? I went down from 8 to 5, so I went down 3. How do I say down? I say negative. So my rise was negative 3, and what's my run? Well, I went over from 2 at this spot, I went over just 1 spot, so that is 1. So m equals negative 3 divided by 1, that is a value of just negative 3. Perfect. And what's another way I could figure that out? Well, if I look at my equation here, look at that. My m value there is negative 3. And if that's not enough, there's also another way that we remember from last time. We can just take a look at our rate of change. We would take 5 minus 8, and that would give us a value of negative 3. That would give us 2 minus 5, which is negative 3, and you can see that the trend will continue. The best way to do it, though, always, always, always take a look at our equation. It tells you everything you need to know. Okay? Okay, so it says Mike earns $12 an hour working at a video store. Create a table of values for his earnings of work. So for that, I always think it's easy to develop an equation. So why don't we try to find an equation, y equals mx plus b. So remember, our m is our slope, it's our rate of change. So how much is Mike earning an hour? Because that's how much his money is going to change. So he says it's earning $12 an hour. That's always going to be our m value. That's how our money is changing. So y equals 12x. And the only thing you have to come up with when you're developing an equation is what is our y-intercept? So basically that means what is Mike starting at? That means if he didn't come to work at all, how much money would he earn to start? Well, Mike doesn't have a very good job because if he doesn't come to work, he does not get paid. So that means our b value here would be 0. So we can write y equals 12x plus 0, but generally I don't like writing that plus 0, so I would just leave it at y equals 12x. So that's our equation here. So if he works 0 hours, how much does he get paid? Well, y equals, in that case, y equals 12 times 0. That would give us a value of 0. If he worked 1 hour, how much would he get paid? Well, he would work 1 hour and get paid $12. If he worked 2 hours, 12 times 2, and you make 24, and this would continue and continue. So what is our rate of change? Well, we take a look. 12 minus 0 equals 12. 24 minus 12 equals 12. And we could keep going. That would give me 12, 12, 12. And just like before, what does that tell us? If we have the same number, that means it is a straight line. Okay, so we're going to graph Mike's earnings, labeling all of our axes. So we know that this is our y values, this is our x value. But really, what does that mean? This means this is how many hours he worked, and this is how much he gets paid. So we said if he works 0 hours, he makes $0. If he works 1 hour, he makes $12. If he works 2, he makes 24. 3 is going to make 36. 4 is going to make 48. And 5, he's going to make 60. So here's our nice line right there. And we can continue it forward. So now we're going to calculate our slope. So I'm going to pick any 2 points. I'm going to just pick that point and maybe that point there. And now let's calculate our slope. So remember, m equals rise over run. And if we had to guess, what do we think it would be? Well, if we take a look at our equation, our m value is 12. So hopefully when we calculate this, our m value is also 12. So in these 2 points, what's our rise? Well, we start off at 36 and we move all the way up to 60. So 36 to get to 60, 60 minus 36 is going to give us a value of 24. And then we need to use our run. So we said our rise was 24, positive, and our run is how far we moved that way. Well, we moved from 3 hours to 5 hours, so we moved over 2 spots. Our run was 2. So 24 divided by 2, that's 12. What do we notice about this slope in my answer from A? It is, of course, the exact same, which is exactly what we wanted here. Okay. Only other thing I want to talk about is taking a look at flat and parallel lines. Another way of saying flat is what we call a horizontal line. And in a graph, if this is my graph here, the horizontal line might just look something like this. It's not a very fun line, but it's a very easy line to solve. This graph has a slope equal to 0. So if I want to come up with an equation for that line, we know the equations are y equals mx plus b, but this slope being 0 really makes this very easy for me. I can say y equals mx plus b, but my slope is 0, so it's going to be 0 times x plus b. And if you have anything times 0, it just goes away, so you end up with just y equals b. So really, the equation for this line is whatever point it passes through on our y-axis, so whatever my y-intercept is. So if this passed through the point 3, this line would just be called y equals 3. It's that easy. Okay, so for horizontal line, biggest thing to remember, my m value is equal to 0. What if I have a parallel line? Well, to have a parallel line, you have to know what parallel means. Parallel is when 2 lines or more are moving in the same direction but never touch. The key for that is that means they have to have the same slope. And when I say same slope, it has to be the exact same slope. So if I had 2 lines, maybe like y equals 6x plus 3 and y equals 6x minus 4, are they parallel? Well, all you need to do, don't look at that, don't look at that, you don't care. The only thing you're looking at is my slope. Are they the same? This is 6, this is 6. Yes, they are parallel because they have the exact same slope. And if you were to graph it, one, the 6x plus 3, would probably look something like that. And the other one, the 6x minus 4, might look something like that. But it doesn't matter where their y-intercept is, those things. It just matters that they're moving in the same direction. They're never going to pass. So if I had y equals 2x plus 1 and y equals 2x minus 100, still doesn't matter. These things are parallel because I have the same slope. And the last thing is, what about flat lines? If I had y equals 3 and y equals 7, are these things parallel? Well, you have to ask yourself, what is y equals 3 and y equals 7? We'll take a look. Those things are, remember, are flat lines. If we don't have an x value in there, it is a flat line. So are they parallel? Well, let's take a look by just graphing them. y equals 3 is going to be this, and y equals 7 is going to be this. Are they parallel? Well, definitely, yeah. They both have the same slope. Their slope for these flat lines is 0, and that's why they're flat. And because they're flat and they're both flat, they are parallel indeed. They are never going to intersect at all. So if I ask you, write the equation of a parallel line, all you need to do is come up with another line that has the exact same slope. Okay? And that is it. Make sure you are doing your homework, and we'll see you tomorrow.